Hello everyone. In this video, I'll be explaining question numbers 10, 11 and 12. So first we'll see the question number 10. A lightning bolt with 8 kiloampere strikes an object for 15 microseconds. How much charge is deposited on the object? So now there is an object and on that object a lightning bolt with 8 kiloampere is continuously striking for 15 microseconds. So on that object what is the charge which is deposited? So we must be knowing the relationship between the charge, current and the time. Okay, so we know that I is equal to Q by T, right? So Q is equal to I into T. So here what is the current? It is 8 kiloampere, that is 8 into 10 to the power 3. What is T? It is 15 into 10 to the power of minus 6. So 10 to the power 3 and 10 to the power of minus 6, it will give you 10 to the power of minus 3. And what about this? It will be giving you 120. 15 into 8 is 120. So I can write this as 120 millicoulomb. So this is the charge which is deposited on the object. Okay, so answer is 120 millicoulomb. Next, a rechargeable flashlight battery is capable of delivering 85 milliampere for about 12 hours. So here I said I is equal to Q by T. Okay, it is coulomb but per second, ampere is coulomb per second. This will be the units of this respectively. Okay, I is equal to 85 milliampere, time is 12 hours. So I said this is in seconds. So convert this hours to seconds. So you know 1 hour is equal to 60 minutes into 60 seconds, right? So this one will be 3600 seconds. So 1 hour is 3600 seconds. So 12 hours will be 12 into 3600 seconds. Okay. So now the time is given, the current is given. So what is the charge which is released at this particular rate? So to find out the charge, once again I said it is I into T. So I can write this as 85 into 12 into 36 into 10 to the power 2 into 10 to the power of minus 3. This milli I have written here, this into 2 zeros I have taken it as 10 to the power of 2. So this will be giving you 10 to the power of minus 1. So you have to find out the answer 85, 12 and 36. Okay, 85, 12 and 36. So 85 into 12 into 36. That will give you 36720. So divided by 10, that will give you 3672. So 3672 coulombs. So this will be the answer. If its terminal voltage is 1.2 volts, that means we have given you the voltage, then what is the energy that a battery can deliver? You know the formula for the power, that is equal to work done or the energy divided by the time. Work done per unit time or work done, it is also considered as energy. So another formula you know is for the power, which is voltage into current. We know current, we know voltage. So we can easily find out the power. After finding the power, we also know the time and easily we can find out the energy, right? So energy will be equal to power into time. So this is V into I into T. I into T is nothing but Q, V into Q. So now Q I have already found it out, 3672, and what is the terminal voltage which is given? That is 1.2. So 3672, so this is I will be dividing by 10 into 1.2. So this will give you 4406.4 joules. Okay, 4406.4 joules. So this is the answer. So when you know the voltage, when you know the current, you can find the power, and after finding the power you can find out the energy easily. Okay, so this is the procedure to find out the answer. Let us see this question now. If the current flowing through an element is given by, so this is the expression for the current which is given. We have to plot the charge stored in the element. That means you have to find out Q of T versus T. So for that we have to find the expressions for the charge for this particular duration of time. So the expression for charge will be integration of current, because we know I is equal to dq by dt. So finding the charge will be the reverse process of the differentiation, and that will be your integration. So remember, this one will be t naught to t and I into dt, plus here you have to include the charge at the initial point. Okay, so here the q of t naught for this particular duration 0 to 6. Okay, 0 to 6, I cannot write this 6 here. Okay, it should be t. So for 0 to 6 duration, it is 0 to t. What is current? It is 3t into dt. What is the initial charge? It is 0 coulomb. So it will be 3t square by 2. So this is 1.5 t square, because only this will matter. 0, obviously if you are substituting 0, it will become 0. So 1.5 t square is the parabola. So here what I will do, I will write the values. So this is 6, this is 10, and this is my 15. So after every calculation, I'm going to come here and I'll be plotting it. So this is my value. So this is my parabola. Okay, this is my parabola. So this is 1.5 t square. So what is the value at this particular 6? So you can substitute the value 6. Okay, 36 into 3 by 2. So 36 into 3 by 2, that will be 54. Right? 54 coulombs. So this is my 54 coulombs. Okay, so this is my 54. So next, that is the charge T naught, that is equal to 6, will be 54 coulombs. So next, from 6 to 10 duration. So Q will be equal to T naught is this particular initial value will be T naught. T naught to T. Okay, what is the value of that? That will be 18 into dt plus Q of 6. So here 18 into T, integration of a constant will be T, right? So T 6 plus what is this? It is 54. So here 18T minus 18 into 6, that is 108 plus 54. So this is 18T minus 54. So this is a straight line of the form y is equal to mx plus c. So now this is from 6 to 10. So now after that particular duration, that is at 10 seconds, what will be the charge left? It is 18 into 10 minus 54. So it is 180 minus 54. This is 126 coulombs. Okay. So this is 126 coulombs. So this is 126 coulombs. So this is my straight line. Okay, straight line. It is a straight line which has this particular slope. That is, slope is 18. So next, from 10 to 15, the charge will be T naught. T naught is equal to 10. So this is T. So it is minus 12 into dt plus Q into Q of 10. That is the initial charge which is present till 10 seconds of time. So minus 12t, here you are writing t and 10 plus what is this? It is 126. 126, right? Yes, 126. So minus 12t plus 120 plus 126 minus 12t plus 246. Once again, this is a straight line, but it has a negative slope. Okay, so negative slope. So till where? Till 15. And what is the last value of that? We have to find it out. At t is equal to 15, we have minus 12 into 15 plus 256. So this is 66 coulomb. Okay, 66 coulomb somewhere here. So this is the negative line. And after that, now you got to know this is the charge at 15 seconds. So now 15 greater than or equal to 15. In this case, T naught is 15. This is T. This is 0 dt plus Q of 15. So this is 66 because this is 0. 66 coulomb. So now here you will be having a constant value after 15. So this is the plot of the charge Q of T. Okay. So just remember here T naught means starting of the interval, and t, it should be t only. You cannot take 6 here. But after that, finding the particular expression, you can find out the value of this 6 seconds. Till 6 seconds, what is the charge which is present? That will be the initial charge for the next duration. Again, take t naught as 6, this one t naught. Find out the value till 10 seconds, because the initial charge is also carried out. This initial charge also is carried out. Now we will find out what is the charge till 10. After finding this, you will be finding what is the charge till 15. Okay, so this is the process which is continued. Okay, so this is all about the exercise 1.10, 11 and